Hey. Today we are going to find all anagrams in a string. It's a nice problem. Let me read you the problem statement. Given two strings S and P, return an array of all the starting indices of P. Oh, it's not P. P's anagram in S. Like we are going to return like the first indices of S. If that substring is like anagram of or permutation of P. That's the problem. You may return the answer in any order. Anagram is a word or a phrase formed by rearranging the letter of different words or phrases, typically using an original letter exactly once. That's great. Okay, for this problem, if we are going to pick like substrings, like we are going to use sliding window technique. For length of P, we are going to pick like subarrays of S, and we are going to compare like this window and our P. To compare those elements, we are going to use dictionary. We are going to count how many times they are existed in that substring, and we are going to compare like those existences. I think the problem is like easy. The hardest part of this problem is like implementing the problem. Okay. Let's start with creating dictionary as count and p count. It's going to be an empty dictionary. For the next thing, what we need. Oh, our left pointer is going to be 0, and we need an array to return our result. That's all we need to start. Let's iterate our characters in P and store it in like that P count dictionary, where character in P, what we need to do, P count is going to be P count of character is going to be, we are going to add 1 if the character is existed in the count. To do that, get our character, otherwise 0. I think that's work. P count. Let's try this one. Yeah, it's going to return A1, B1, C1. It's great. After that, we're going to start our sliding window technique. Before that, we need to check something. Okay, if length of P is greater than length of S, what we are going to do, we are going to return our result empty result, because like if the length of P is going to be greater than S, like there is no substrings we can find in S. That's impossible task. After that, we are going to check the first iteration, or like the first case. The first case means like we just pick these elements and these elements, and we are going to compare each other. Oh, before that, like we need to pick the first element, for I in range up to length of P. What we are going to do, we are going to store like in dictionary as count. We are going to pick like the first 3 elements as count of s of I is going to be, oh, we are going to add one s count dot get our s of I 0. I think that's what I need to do. After that, we are going to compare if s count equal to p count. That's our base case. What we are going to do, we are going to store and or append like 0, or in other means like we are just returning the first indexes for the first case. Otherwise we are going to move our sliding window. We just stored 0. Then we are going to slide a window. To slide it for our in range, we are going to start with length of p until length of s. That's how we are going to iterate it for remaining slides. After that, like we need to add the next value. At this time, we are going to increment add e and like store in 1, like e is existed just once, and we are going to delete the first letter c. To do that, what we are going to do, okay, s count of s of r is going to be, we are going to add s count. Oh, I just forget get of s of r. Tell me something. I should open the bracket or 0 to add our right pointer, and we are going to like decrement s count of s of r is going to be decremented by 1, and we are going to delete that value. We are just deleting like we are decrementing the numbers. After that, we are going to ask something if s count of, oh, why should I decrement our right pointer? We are going to decrement left pointer of L is equal to 0, and our decrementer is going to be 0. We are going to delete this function, this value. We are going to delete s count of s of r. That's how we are going to do it. Why should I always say r? It's going to be delete r left. After that, left is going to be incremented by 1. After that, we are going to check our current window. To do that, like I did it in here, we are going to check if our s count equal to p count. What we need to do, we are going to append in our result our left pointer. After that, we are going to return our result. I think that's the whole idea. We just put it the existence of each characters in our dictionary, and we are going to compare it. If that's equal to, we are going to return the first index. Otherwise, we are going to return empty array. That's behind the logic at this problem. I think it's work and it's pretty efficient. Thank you guys.